So, hello everyone and welcome back to the channel. I hope you all are doing great. In today's videos, we are going to solve a really interesting geometry and combinatorics problem counting how many horizontal trapezoids can we form from a set of points on a 2D plane. This problem looks tricky at first, but once we break it down with smart observations, it becomes surprisingly simple. So grab your notebook and let's dive deep into the explanation. So here problem is we are given an point, we are given n points, and each point has coordinates x comma y. We need to count how many horizontal trapezoids we can form using any four distinct points. A horizontal trapezoid is a quadrilateral that has at least one pair of horizontal sides. That means two sides must be parallel to the x-axis, which translates to like they must be lie on two distinct y level, and each y level must have at least 2 points. Because a horizontal side need 2 points, here is the we can also see a key observation that a horizontal trapezoids form only when you pick 2 points from one y level and pick 2 points from another y level. So the problem becomes from every y by x coordinate level, choose combination of 2 points and multiply it with combinations from every other y level. This turns the problem from geometry into pure combinatorics. Now, let's explain the code by line. In line number 1, okay, in the left side of the display, in line number 1, class solution, we start by creating a solution because competitive platform expect this structure. In line number 2, this is the function name the judge is expecting. It takes points as input. Okay. In line number 3, mod is equal to 10 into n plus 7. Since the result can be huge, we always apply modulo, that means 10 9 plus 7, 10 9 plus 7. In line number 5, from collection import default dict, we import default dict so we can store the count of points for each y level easily. From line number 7 to 9, yes, group point by coordinate, that is count is equal to default dict int for x comma y in points. Okay, that is count y plus is equal to 1. Here what we are doing, we create a dictionary that map y coordinates is what, how many points have this y. Every time we see a point, we increase the count of its y level. And why do we group by y? Because horizontal lines are determined by y value. Okay, so come to the next line, that is line number 12 to 16. Yes, like here we compute c k comma 2 for each level. Okay, so a is equal to, for k in counts dot value, if k is greater than is equal to 2, a dot append k into k minus 1 by 2 percentage, yeah, divide mod. Okay, here for each y level, let k be number of points you can perform, you can form c k comma 2 pair of point on that level. If k is less than 2, you cannot form a horizontal line. So a becomes a list of number of horizontal segment per y level. Okay, in line number 19, if lane A is less than 2, return 0. To form a trapezoid, we need two different y level, each with at least one horizontal line. If there are fewer than two, return 0. Okay, in line number 21 and 22, that is, and 23 2. Yes, sum A is equal to sum A mod sum A2 is equal to sum A into A mod for A in A mod. Okay, here we compute two things. First one is sum A is equal to sum of all ck comma 2. In second time, it's sum A2 is equal to sum of a square of each. This is need to compute pairwise multiplication efficiently. In line number 25, and yes, that is core formula, that is total is equal to sum A into sum A minus sum A mod. We use identity. Okay, we have mentioned in the means the deep explanation. Okay, you can see the algorithm. Okay, I'm not here to explain the algorithm. You can I have just put my algorithm in the description thing. Okay, you can take from that. Okay, so this avoid nested loops and make the solution 0 n. Okay, in line number 28 to 29 and also to the 30, that divided by 2 in modular arithmetic in 2 is equal to power 2 comma mod 2 mod total is equal to total into in 2 divided by mod. Okay, because dividing by 2 in modular arithmetic means multiplying by the modular inverse of 2. Okay, so the final line becomes return total. We return the final answer, that is total horizontal trapezoids. Okay, so from this question, how we smartly convert a geometry problem into a combinatorics problem using grouping, combinations, and powerful mathematical identify. Okay, so this approach runs in linear times and easily handles one crore points, so it's both efficient and elegant. If you find the explanation helpful, make sure to like the video, subscribe to the channel, and comment which topic I should explain next. Okay, so happy coding and goodbye.